Hi, this is Algebra 2, Lesson 17. We're going to talk about subscripted variables and angle relationships. We're starting on page 86. Subscripted variables. We're used to using x and y for linear equations, but there are times when other variables make more sense. Often we use subscripted variables to help remember what the letters represent. You will be doing this often in physics and chemistry as well as in math. We're going to practice working with subscripted variables by working out problems involving money and with distance, rate, and time. Okay, so here's the first example. Solve the system. NN is number of nickels plus ND is number of dimes equals 40. And 5 times the number of nickels plus 10 times the number of dimes equals 250. Now you remember when we're doing coins, this means the number of nickels plus the number of dimes equals 40 means we have 40 coins and they're made up of dimes and nickels. 5 times the number of nickels gives us the value of the nickels. 10 times the number of dimes gives us the value of the dimes. So this means that the 40 coins add up to $2.50. Remember when we're doing coin problems, as long as we're doing the values represent the number of cents. So this is 5 cents and this is 10 cents. So this has to be cents too. We can't mix our units. So we can't say $2.50. We're going to say 250 cents. Okay? So the whole problem is in cents right now. Okay, so we have this system. We could use either substitution or elimination to solve it. For substitution, we could solve for the number of nickels would equal 40 minus the number of dimes, or the other way around, the number of dimes would equal 40 minus the number of nickels. Or we can use elimination by multiplying one of the equations by the lowest common denominator of the coefficients of one of these. So let's do elimination since that's one we haven't practiced as much. And let's multiply the top equation by -5. So that would be -5 times the number of nickels minus 5 times the number of dimes equals -200. And we're going to add that to 5 times the number of nickels plus 10 times the number of dimes equals 250. We add these together. The number of nickels cancels, and we're left with 5 times the number of dimes equals 50. And now we can solve for the number of dimes. Divide by 5, and the number of dimes equals 10. So there are 10 dimes. Once we know the number of dimes, we can solve for the number of nickels. Let's do it in both equations to check ourselves. We should get the same number of nickels from both equations. So the number of nickels plus the number of dimes equals 40, and the number of dimes is 10. So the number of nickels equals 30. And the other equation is 5 times the number of nickels plus 10 times the number of dimes equals $2.50. Sorry, ran out of room there. So we have 5 times the number of nickels plus 10 times 10 equals 250. 5 times the number of nickels plus 100 equals 250. Subtract 100 from both sides. And we get 5n equals 150 divided by 5. And the number of nickels equals 30. Okay? Let's try another one with rate, time, and distance. The rate of Mike times the time of Mike plus the rate of William times the time of William equals 260. we remember rate times time equals distance. So the rate of Mike times the time of Mike is actually the distance Mike went. The rate of William times the time of William is the distance William went. So Mike's distance plus William's distance equals 260 miles or kilometers or inches, whatever the distance we're talking about is. The rate of Mike is 40. That could be 40 miles an hour or inches a week. The rate of Will equals 60. The time of Mike plus the time of Will equals 5 hours or weeks or millennia, whatever unit of time we're using. Okay, we know the rate of Mike and the rate of William, so we can put those up there. So really, we need to find what we don't know is the time of Mike and the time of William. So that's what we're going to solve for. So let's start by solving for the time of Mike. The time of Mike equals, if we subtract the time of William from both sides, it'll equal 5 minus the time of William. Okay? Now we can substitute, because the time of Mike equals 5 minus the time of William. Every time we have the time of Mike up here, we can substitute it with 5 minus the time of William, because these are the same values. So we're not changing the value of the equation. So we have the rate of Mike, we have the rate of Mike, which is 40, times the time of Mike, which is 5 minus the time of William, plus the rate of William, which is 60, times the time of William equals 260. Okay, now that we only have one variable in the equation, we can solve for the time of William. So we're going to distribute here. We'll have 200 minus 40 times the time of William plus 60 times the time of William equals 260. Okay, let's put these two like terms together, and we'll have 200 minus 20 times the time of William. That's plus 20 equals 260. We can subtract 200 from both terms, or from both sides rather. And 20 times the time of William equals 60. And now we can solve for the time of William by dividing by 20. The time of William equals 3 hours or weeks or centuries or millennia, whichever it is. Okay, if the time of William is 3, then we should be able to solve for the time of Mike. The time of Mike equals 5 minus the time of William. So the time of Mike equals 2. Okay? Okay, angle relationships. They're making solving angles a little more complicated now by using two variables. We're going to solve them the same way though. So we have two parallel lines and a transversal. We need to find x and y. We see that the small angle here is 50 degrees and the large angle is 7x minus 2y degrees. And down here, this angle is 5x minus 10y. Okay, there are a couple places we can start, but first of all, we can remember that as a line transverses two parallel lines, the large angles are going to be equal and the small angles are going to be equal because this line is cutting them at the same slope. So that means 5x minus 10y equals 50. So let's start by writing that down. 5x minus 10y equals 50. Okay? We also can see that these two lines are supplementary. If we add these together, they make a straight angle. That means that 7x minus 2y plus 50 equals 180. Right? We can make this a little cleaner by subtracting 50 from both sides. And now we have 7x minus 2y equals 130. Okay, so now we have 5x minus 10y equals 50, and 7x minus 2y equals 130. We can set these up as a series of equations and solve them using substitution or elimination. So let's rewrite them so we can look at them. We have 7x minus 2y equals 130, and we have 5x minus 10y equals 50. If we use elimination, we're going to have to multiply this top equation by, let's do it by -5. That'll change this to a +10, so that it'll cancel here. Okay? So we're going to multiply this whole equation by -5. So that'll make this -35x plus 10y equals -650. And we're going to add that to 5x minus 10y equals +50. Right? Now our y's cancel. We have -30x equals -600. Divide by 30. And x equals 20. Okay? If x equals 20, we can substitute the 20 into both of the equations and solve for y. So we have 5 times 20 minus 10y equals 50, and we have 7 times 20 plus 2y equals 130. Okay? So 100 minus 10y equals 50. Subtract 100 from both sides. And -10y equals -50. -50 divided by -10 is going to be y equals 5. Okay, let's try that over here. We have 7 times 20 is 140 plus 2y equals 130. Sorry, this is a negative. That was not working out. Okay. Subtract 140. And we have -2y equals -10. Divide both sides by -2 and we get y equals 5 again. So that's your answer. X equals 20 and y equals 5. Okay? That's it for this lesson. Try your practice problems, do your homework, and let me know if you have any questions. Thank you.